Hello students, welcome to my YouTube channel Electrical Engineering. Today I am going to discuss the DC to AC converters, which are also called inverters. In sinusoidal pulse width modulation, we have a sinusoidal waveform and we have a triangular waveform which is called carrier waveform, and the sinusoidal waveform is called reference waveform. There is a comparison between these two waveforms, and the comparator output is obtained, which are actually pulses whose duty cycle is sinusoidal in nature. So this is the waveform of a single phase bipolar sinusoidal pulse width modulation inverter, and this is also single phase bipolar sinusoidal pulse width modulation inverter. There are four switches, and we are getting two waveforms to control the triggering of these switches. This is called single phase unipolar sinusoidal pulse width modulation inverter. The output of unipolar SPWM inverter, there are four outputs, and one output is used for one switch, which can be seen in this slide. This is one output. We have to complement this and it will give the second output. Similarly, we have to invert our reference signal by multiplying it with -1, and again we will do the comparison of this reference waveform and the same carrier waveform to get the pulses. And first pulse will go to the gate terminal of IGBT3, and we will complement these pulses to apply these complemented pulses to the IGBT4. So this is the implementation of a three-phase unipolar PWM inverter. These are the switching waveforms which are obtained as a result of comparison. And in three-phase PWM inverter, the gate signals are produced in this way. This is the circuit diagram. These gate pulses are coming from the PWM generator. There are 6 switches, and these are the three phases of the output. We have to connect an LCL filter to convert the PWM pulses to ideal sinusoidal waveform. So these are the output of unfiltered three-phase PWM inverter. In order to design filter components for single-phase inverter, these are the taken steps. This is the voltage across the inductor. An inductor is connected between the DC bus and the AC output. So V bus minus V out will be equal to the inductor voltage, and if inductor voltage is equal to inductance multiplied by di by dt, and di by dt can be written as delta I peak to peak divided by duty cycle into sampling switching time. From here we can calculate delta I peak to peak, and it will be given by this expression. For PWM inverters, the duty cycle is a sinusoidal waveform. The duty cycle is sinusoidal in nature, where MA is called the modulation index, and its value is given as the ratio of the reference waveform, amplitude of the reference waveform to the amplitude of the carrier waveform. V output is equal to V bus into the duty cycle, and by putting these values in this equation, we can calculate delta I peak to peak. So after doing some modifications, delta I peak to peak will be rearranged as this expression. So this is the expression for delta I peak to peak. In order to find out the maximum swing in the output current of the inverter, we have to calculate the local maxima of delta I peak to peak, which is calculated by taking the derivative of this expression and equate it equal to 0. So after doing some modifications, we get this expression And at the end we get 1 minus 2 ma sin omega t equal to 0, which means ma sin omega t should be equal to 1 by 2. So we can put this condition in this expression and we will get delta I peak to peak max. And it is given by V bus divided by 4. The reciprocal of the switching time is the switching frequency, and this is Li. And we can calculate Li from this expression. Similarly, we can calculate the capacitance of the LC filter. So for this data, the calculated value of the inductance is 8.83 millihenries, and the calculated value of the capacitance is 0.286 millihenry. So we can do the MATLAB implementation of this single phase inverter. So this is a single phase full bridge inverter, and this is the LC filter. We can initially disconnect this LC filter from the circuit and we can examine our AC output. These are the generation of unipolar PWM signals for these switches, and this is the implementation of bipolar PWM signals for these 4 switches. If we consider unipolar technique, then we just have to run this simulation and we can examine our output. So you can see at the output we get the PWM pulses. Now we can use the bipolar PWM technique. For this case, we have to rename this to PWM5. This will also become PWM5. This will become PWM6. This will become PWM6. Now I can run this simulation. This is bipolar PWM pulses. Now if I want to do the filtration, I have to connect this LC filter in parallel with the load. This is how I can connect this LC filter with the circuit. Now check the values of this filter inductance. This is 8.83 millihenry, which is calculated by this filter design method. Similarly, we can check the value of this capacitance, 286 microfarads or 0.286 millifarads. All other switching values can be seen. The amplitude of the sinusoidal reference waveform is 1. Frequency is 50 Hertz. Similarly, we can see the repeating sequence. This is how repeating sequence can be generated, and this is a bipolar PWM technique. If I rename my PWM signals to PWM5, PWM6, then these signals will be used, and these are the signals which are generated by the bipolar PWM technique. So now I have connected the filter components. Now I will run this simulation again, and if we see the output, it is pure sinusoidal waveform. Similarly, we can check our output. For unipolar PWM, again I am getting the ideal sinusoidal waveform with this filter present. Similarly, we can also implement 3-phase inverter, and there are 3 reference waveforms, and this is the LCL filter which is connected over here. When I run this simulation, I get 3-phase ideal waveforms. We can also check this scope. So these are the 3-phase waveforms. We can also see the sinusoidal reference, and the triangular carrier. So I hope that was a good understanding session for you. If you want to see more similar videos, please stay tuned to my YouTube channel. Until the next video, it's goodbye.